In this video, we are going to solve the following problem. It says, solve the following equation for theta on the interval from 0 to 2 pi. So notice here they give the interval in terms of radians, right? There's no degree sign. So in this problem, we are using radians, and so we want to express all the solutions in radians. So what we want to do for this particular equation, 2 secant theta plus 7.15 equals 0, is we want to solve for the trig function itself. So the first thing that we would do is to subtract 7.15 from both sides. And that will get us closer to having the trigonometric function secant theta, right, by itself on one side. And then we can completely get the secant theta by itself on one side if we divide both sides by 2. And so we wind up with secant theta equals negative 7.15 divided by 2. Okay, so negative 7.15 divided by 2, that's going to come out to be negative 3.575. And that value, negative 3.575, is definitely not one of the values of the on the unit circle standard, the special angles, right, on the unit circle. But also we have an issue over here. That means basically we're going to have to use our calculator on this problem, right? And remember, our calculator, the standard calculator, has inverse cosine, inverse sine, and inverse tan. And this is secant right here. So what we're going to have to do is express this in terms of the reciprocal function, right, for secant, which is cosine. All right. So 1 over cosine theta is the same as secant. All right. And so you can kind of think about this as two fractions being equal, right? So we can cross multiply. When we cross multiply here, we get negative 3.575 cosine theta. And multiplying here, we get 1 times 1. And then so I can get the cosine by itself on one side by dividing both sides by negative 3.575, like so. So I get cosine theta equals negative 1 over 3.575. All right, so now we have this trigonometric equation solved for cosine theta. Right, we have cosine theta by itself on one side. And now what we can do is go to the calculator, right? And we can take the inverse cosine, right, of negative 1 over 3.575, like that. All right, and so let's go ahead and do that. On Desmos here, I have to write that as arc cosine, and then negative 1 divided by 3.575. And you can see we get this value here, and let's just round it to 2 decimal places, right? So we get 1.85 to 2 decimal places, all right? So that's one of our solutions. So remember, on most of these problems that are in the homework assignment, you're going to get 2 answers. And the thing that you have to remember about this is that first off, we're using the inverse cosine, right, to get the value 1.85. And the number that we're taking the inverse cosine of is negative, right? It's negative 1 divided by 3.575. That's negative, right? And so the thing to remember, one, is that the inverse cosine, right, is always going to give you an answer that's from 0 to pi. Okay? And this is in radians. And so this angle, right, is somewhere up here in the second quadrant, right? And we know that because for angles up here in the second quadrant, the cosine is negative, right? And angles over here in the first quadrant, the cosine is positive. So we know, because this number is negative up here, right, that this angle 1.85 is in the second quadrant. And because inverse cosine always gives you an answer from 0 to pi, right? And we can actually look at the number, right? 1.85 is less than pi, which is around 3.14, but it's bigger than pi over 2, which is about 1.57. So it's somewhere over here, okay? All right, so there is another solution from 0 to pi, right? And that solution would be down here, right, in the bottom, directly below, down here. Because we know that the cosine is also negative, right, down in the third quadrant, and it's positive over in the fourth quadrant. So there is another angle down here in the third quadrant, right, that we can that is a solution to this, right? And in order to get that, what we're going to do, right, is subtract this answer that we got here from 2 pi. Okay, so we're going to be doing 2 pi minus this angle. All right, so if you look at it, right, this is the angle that we got, right? 1.85 is this angle right here, which is going to be the same as this angle right here. So that would be similar to going all the way around, right, the unit circle, all the way around, and then going back, right, this angle right here, right, this angle right here, and will take us right back to here. So our other answer, right, that we're going to get for this particular problem, and when you're using inverse cosine, is going to be 2 pi minus the inverse cosine of minus 1 over 3.575. Okay? So for the inverse cosine, that's what you would do. Wherever your angle is that the calculator gives you, right, then you subtract that from 2 pi to get the other answer, right, if you're trying to find the answer from 0 to 2 pi. And there's a couple of edge cases that I won't mention in this video, but I'll give a summary of those. Okay, and so now going back over here and calculating that out, it would be 2 pi minus inverse cosine of that, and we can see we get 4.432 decimal places. Okay, so that would be our other answer on this problem. And that is it on this one.